Hello students, this is Dr. Ruchira Chaudhuri and today we'll solve some problems of differential equation related to JEE Mathematics. So let's start. Now let's come to the first problem. This is the first problem. The degree of the differential equation this is, there are 4 options and you have to find out the correct option. So you'll have to find out the degree of this equation. What is order and degree of a differential equation? Now the order of the differential equation is the order of highest order derivative present in the equation. So if I ask you the order of the differential equation, then the order will be 2 because the highest order derivative present in the differential equation is second order. So the order of the differential equation will be 2. Now what is degree of the differential equation? The degree of the differential equation is the power of the highest order derivative present in the equation after it is free from any fractional powers of the derivative. So degree will be the power of the highest order derivative present in the equation. So at first we will have to make the differential equation free from any fractional power. Then we will have to find out the degree of the differential equation. So this is the differential equation and I can write it as dy dx whole square whole to the power 5 equals to d2y dx to whole cube. Now the differential equation is free from any fractional powers. So the degree will be 3 because the highest order derivative present in the equation is 2 and the power of the highest order derivative is 3. So 3 is the degree of the differential equation. D is the correct option. So let's come to the second problem. The solution of the differential equation this is, there are 4 options and we will have to find out the correct option. So in that case, to solve the differential equation we will have to separate the function of y and function of x and take function of y with dy and function of x with dx and integrate separately and get the result. So I am solving this problem. So dy dx will be equal to e to the power y e to the power x plus e to the power minus x. I am taking e to the power y as common and this is the term with e to the power y. Now e to the power minus y into dy equals to e to the power x plus e to the power minus x dx and integrate, and whenever we will integrate there will be a constant c. So there will be minus e to the power minus y equals to e to the power x minus e to the power minus x plus c, and you can take constant as minus c. So if I take minus c, there this minus will be there and there will be plus. So I am taking minus c. So ultimately the solution will be e to the power minus y e to the power minus x minus e to the power x plus c. So B is the correct option. Let's come to the third problem. This is the third problem. The solution of the differential equation this is, there are 4 options and there is a condition y at x equals to 1 is 1 and there are 4 options and you will have to find out the correct option. So let's solve this differential equation. Now this is clearly d of xy. So x dy plus y dx equals to d of xy equals to xy dx, and now I can take xy in left hand side. So d of xy divided by xy equals to dx, and if we integrate there will be constant. So log of xy equals to x plus c. So xy equals to e to the power x in dot e to the power c. E to the power of x plus c means e to the power x dot e to the power c, and this I can take as a constant. So xy will be equal to a e to the power x, and if I put x equals to 1 in this equation, so there will be 1 equals to a e to the power 1. So a will be 1 by e, and if I put the value of a in this equation, so there will be xy equals to 1 by e dot e to the power x, means y equals to e to the power x divided by ex, and clearly B is the correct option. So let's come to the fourth problem. This is the fourth problem. The order and degree of the equation whose solution is given by this equation. The solution of the differential equation is this: y equals to cx plus c cube minus 4c to the power 3 by 2 plus 7, where c is an arbitrary constant and r, these are the four options, and you will have to find out the correct option. So we will have to find out the order and degree of the differential equation whose solution is given by this equation. Now at first we will have to find out the differential equation. So we will have to find out the differential equation from this solution. So let's first differentiate this equation. So dy dx equals to c, because all of these are constants and this will be 0, so the dy dx will be c, and so the differential equation will be y equals to dy dx x plus dy dx whole cube minus 4 dy dx. Just place the value of c, and so here dy dx will be there in place of c to the power 3 by 2 plus 7. This is the differential equation. Now we can find the order and degree of the differential equation, but notice that here clearly the order of the differential equation will be 1, because the highest order derivative is present in the equation is 1. So dy dx, so the order is 1. Here only in the option B order is 1, so this is the correct option. But to explain, to clear your conception, I am explaining this solution. So to find the degree of the differential equation, you will have to remove the fractional power of the derivative, highest order derivative. To remove the fractional power, we will have to make square from both sides. So y square will be this whole square, and if we make square of this right hand side, there will be the power 6 in dy dx, this term. In the second term, there will be the power of dy dx will be, power of dy dx will be 6. So degree is highest order, the power of highest order derivative, that is the power of dy dx is 6, highest power. So this is the answer. So it can be explained in another way. In this equation, if you notice carefully, there is only one arbitrary constant. So in the differential equation, the highest order derivative will be 1, that is dy dx, and here only you can find the order 1 in the option B. So B is the correct option. So students, these are the 4 main problems that we solved in this class, and in my next class I will solve more differential equation, that is mainly will be about linear differential equation. So stay connected and follow my next video link.